Living on a planet has a lot of advantages, like strong gravity to keep us from flying off into space, and the magnetic field and an atmosphere to protect us from damaging solar radiation. But what if an advanced civilization ran out of room to grow on their home planet? What if they ran out of energy and resources to keep themselves going? Well, their best bet might be to build settlements in space so they could capture more of their star's energy. Not another planet, though. I mean just sort of floating around out there. There's a whole field of science that deals with how that might work. It's called astroengineering, and it's full of really cool, though still very hypothetical, ideas. One of the most famous astroengineering concepts is known as a Dyson sphere, an object that captures more of a star's light and converts it into useful energy. It's named after Freeman Dyson, an astrophysicist who published a paper on this concept back in 1960. He pointed out that only a tiny amount of the sun's light output hits Earth, since the rest is emitted in other directions. And he proposed that other civilizations might have had to build some kind of structure to harness more energy from their local star, and could now be using so much energy that we'd be able to detect their waste heat from here on Earth. But he didn't go into detail about how that might work. Since then, astroengineers have been developing the concept, and one of the more well-known possibilities first showed up in the 1930s science fiction novel Starmaker, and has been featured in lots of stories since then. What if they had a huge spherical shell surrounding their sun like some kind of cosmic egg? If their home star was similar to ours, and they built it with a radius of 1 astronomical unit, or AU, which is the distance from the Earth to the sun, then every point in that sphere would get the same amount of radiation as here on the Earth. Add up all the points on the shell, and that's a lot of solar power, which would be great for a civilization that was low on energy. And there's a bonus. If they fixed up the surface of the shell with a nice atmosphere and a comfortable habitat, it would also provide a much larger area to spread out into. But of course, there are lots of obvious limitations. A structure so huge would probably need more building material than exists in our entire solar system, though another solar system might have more to work with. But then the sphere, constantly be exposed to sunlight, would be too hot for life, electronics, and maybe even the structure itself. They could try building a bigger one so that the shell would be farther from the sun and wouldn't get as hot, but then they'd need even more stuff to build it. Either way, they'd have some gravity problems. Standing on the outside of the sphere, they would only feel the tiny pull of their home star. And if they were on the inside of that shell, they'd feel the same pull and start floating toward their sun. You could try to get the sphere spinning to simulate gravity, but it would take a lot of energy, and you'd still only get an Earth-like gravitational pull near the equator. On top of everything else, on the inside of the sphere, the gravitational attraction cancels out, so it would basically be free floating around their sun. Any minor nudge, like from an asteroid hit, would set the thing drifting, and eventually it would crash into the star. So what if they built a swarm of smaller structures and spread them out around the sun, instead of one huge rigid shell? That might be a little more doable. It's the same concept as the Dyson sphere, because they're spreading out around the sun to gather more of its energy. It's just not a sphere. For example, they could try using solar collectors, devices that capture the sun's energy, balanced on solar sails, thin mirrors designed to be pushed around by the pressure of the sun's radiation. Then they could stick them right where the inward pull of their sun's gravity would be just as strong as the outward push of its radiation. They'd be like space power plants, transferring the extra energy they collected to smaller, more self-contained space habitats. But with all these hurdles, humans are nowhere near being able to build a Dyson sphere or anything like it. But we are looking for signs that other civilizations might have. In the process of gathering and using all that energy, they'd produce lots of extra heat, mostly in the infrared part of the spectrum. That's why astronomers are scanning other galaxies for infrared spikes that seem like they shouldn't be there. So these huge astroengineering projects might have to stay theoretical for now, but trying to figure out how they might work gives us new ideas about how to look for other life that could be out there in the universe. Thanks for watching this episode of SciShow Space, and especially to our patrons on Patreon who help make this show possible. If you want to help support this content, just go to patreon.com/scishow, and don't forget to go to youtube.com/scishowspace and subscribe.